Hey everyone, welcome to this tutorial on the line tracking sensor. We're going to be using this sensor for a few different things. We're going to be using it to make our robots stay on a piece of paper so that they can not move off said piece of paper, as well as we're also going to program them such that they can follow a path. So let's start with the first program. And to work with both of these programs, I'd like you to have 3 line trackers available to you. So the line trackers kind of look like this, and hopefully you can see that. But I also want you to have the line trackers underneath your robot, underneath the front of the robot, spaced like this is fine, and they have to be between 1/8 and 1/4 of an inch away from the ground. So if you don't know how much that is, go get a ruler out, look at 1/8 of an inch to 1/4 of an inch. It's not a lot of space. But if it's any higher, then these things don't read well. Okay, now depending on the value, a darker value will give these a value of up to 4095, and a lighter value will give it a value up to 0. So just keep that in mind, and let's go and program. So these line trackers just detect different colors, and they work best with black and white, but you can use other colors with them as well. Okay, so in task main, let's do this one from scratch. Let's say while 1 is equal to 1, squiggly bracket, so enter squiggly bracket, enter if parenthesis sensor value capital S capital N of, let's say, line tracker 1 close parenthesis is, let's say, less than, and we're just going to try a value out here, 1000 close parenthesis, and then we're going to put a squiggly bracket, enter. Then let's have our motors do something, and we're going to specify the motors. So go to your motor and sensor setup, go over to motors, and then based on where your 2 motors are, I'm going to imagine that my left motor is plugged into port 1, and if it's not, then make sure yours is plugged into whichever port you say it is, Vex 393, and my right motor is on port 10. And if yours is not, please keep that in mind. Also, if the wheels spin in the wrong direction, remember you can always go back here and just turn on reversed, and that will flip the motor around. Okay, so I'm going to hit apply, get those 2 motors. I'm also going to add in my line trackers. Line trackers can read a number of values, so they're analog sensors. And I'm just going to call them based on where they're located. So the one on the closest to the left, I'm going to say this line tracker 1, line tracker 2, line tracker 3. Okay, so over here, line tracker 1, and that's a digital in, or in this case, a line follower. Then line tracker 2, and line tracker 3. Whoops, line follower. Apply. Okay, and now we got those 3. So we're pretty much saying if we're going to put this on a piece of black paper, okay? And we want the robot to stay on this piece of black paper. So if it's rating a dark value, it's going to be over 1000. But if by chance it gets off the paper, that means it's going to read the color of white, because that's going to be the border of the paper. And it's going to then, we want the robot to turn back onto the paper. So if it reads a value of 1000, then let's get our motors to do something. So motor, whoops, I accidentally hit compile. Motor, square bracket, so hold down shift to, don't hold down shift to generate a bracket. And then we're going to say, since that was this one over here, if you imagine where that is on your robot, that's on the left side. So then we want to turn the left motor. So motor, left motor, close square brackets, we'll say is equal to, let's go half speed, so 63. Semicolon, enter. We'll say motor, square bracket, right motor, close square bracket, is equal to 0. And then put the semicolons on. And if you think about that, like, we're turning just one of the motors because it's off the paper. If this one's reading a value less than the black paper, it's going to be turning the robot hopefully back onto the paper. And if it's not, if it's going backwards or something, you can just calibrate that. Okay. So that's the first one. Enter, close squiggly bracket, enter. Next one's going to be, and let's just copy this code down that we just did for the if. It'll just save us a little time. And I'm going to paste that. If the sensor value of line tracker 3 is less than 1,000, so that means that one's off the paper, then we want this to be 0 and this to be 63 so that it turns back onto the paper via the right side. And then lastly, let's add a condition for both. So I'm going to paste that if statement one more time. And this is going to be if the line tracker 1 is, let's say, greater than 1,000, space, and I want you to put 2 ampersands, so and, that's, you get that by holding shift and pressing the 7 key, and sensor value for line tracker 3 is greater than 1,000. That means both are on the paper, on the black paper. Then we want both motors to move at 63. And there's a good chance that one of these are inversed, so maybe it's negative 63. But just make sure it's going in the correct direction. Okay, after that we got to make sure we close off our squigglies. So this squiggly is going to the while, so we need one more that's going to go to the task main. Okay, so that one goes to task main up here. I just count the squigglies. So everything should have a squiggly that started with a squiggly. Go ahead, click compile and save your program. And hopefully after you've done so, there were no errors. So make sure everything is plugged in where it needs to be plugged in. Give it a go and see what happens. The teacher should hopefully have some black and white piece of paper in the room, and you can just execute it and see what happens. And if it doesn't quite work out the way you're hoping, then calibrate it and figure out how to modify this code in order to make it work for your specific robot. Okay, that's going to conclude this video. Hopefully you found it useful, and I will see you later.